Hello everyone, hope you all are doing well. So today we will start our new topic, that is potential energy. So talking about the definition of potential energy, that what is potential energy. So any energy that happens due to its position, any energy due to energy, you can say that energy produce due to its position with respect to some you can say that with respect to some observed in force field, with respect to some observer in force field. So this, like previously we have learned the definition that anything that is having position or having location is potential energy, but now we are in senior classes, so we just have to make a new make some long definition, that energy produced due to its position means wherever we are having position, we are having producing of energy with respect to some observed, or you can say some observer in force field, means in a force field. Now like we can also write with this one that some observer in force field means that potential energy PE, potential energy is a field associated energy, is a field associated energy, means potential energy is also called a field associated energy. It's connected with the fields. Like which kind of fields we can write here? Number 1, electric field. Number 2, we are having magnetic field, you can say. Number 3, we are having gravitational field. So these are the field that potential energy is associated with. These field like to produce energy. After that, it's having some reference point. What it's having? It's having some reference point, you can say. How some reference point? So I will explain you further that it's have a need of some reference point. Some reference point means that the opposition of height, means we need some reference. Like if we are standing on a building, we are at the top at the height. Like let me make a diagram after some time. Just wait. Some reference point. After that, we are having one more thing, that we are having conveying or attractive, you can say conveying or attractive field, having positive charge, and then we are having repulsive, and we can also say it that what the word is, diverging just wait, diverging or repulsive field having negative charge. Now let me make a diagram first. Okay, so here I will make a diagram. Just wait, let's see. Like here first I said that we need some reference point. What are some reference point? Like let me show you. Like these are some reference point. If we are having first reference of any person is standing over here, so this is on height, means on height. Second person is standing over here. Now these are the two reference. First reference standing here, second reference here. Now at the top over here we are having one pendulum. Okay, now from his height this pendulum is nearer, means having reference, nearer reference, and according to this it's a far away from this one reference. So these are the reference point. Like in potential energy we should know the position, means we should know the reference points. After that, move to next, that it says a conveying or attractive field. How conveying or attractive field have a conveying and attractive field having negative charge, by the way. I just wrote over here wrong. And repulsive have positive. Like in potential energy, what happens that the thing that attract more, like we are having earth over here, okay. Now anything is attracting, like a ball is attracting towards it, so it will get a negative charge in potential energy. But one thing is here, that it's a like earth again, but when it's repulsive, or you can say diverging, going far away, it will get a positive charge of potential energy. So these are the two main difference of conveying and diverging. Now let's move further. We should know the formula of potential energy. As we all know that potential energy is equal to mgh, means it's need a mass, having gravity, and on a height, as I told you in reference point. Now we can also say that the potential energy is directly proportional to height, because whenever we will be having height, like if we are having any object, specifically we know that it having mass and gravity, but it's directly proportional to height. It should also have a height, so it's called the potential energy. After that, talking about it's a scalar quantity. As we all know that it's a scalar quantity. Its SI unit is joule. Okay, so these all are the just some points of the potential energy. Now let's move further, that is work energy principle. Okay, as you all know that in last lecture kinetic energy, we all again also proved the work energy principle. In this one we will again prove work energy principle, but according to potential energy. So here we said that work is equal to change in kinetic energy plus, you can say that change in potential energy. Means work is equal to change in kinetic energy plus change in potential energy is called work energy principle. But how? Just let me show you. I will make a diagram in which you can easily understand that how work energy principle is just working over here. So moving towards there, like here we are having, this is our earth, okay. Now here one thing we are having, that is in rest. It's a one object. When it is in rest, so its kinetic energy will be 0, its potential energy 0. When its kinetic energy 0, kinetic energy is directly proportional to velocity. It means its velocity is 0, and its height, potential energy height, is directly proportional, so height is also 0. But what we did, we put some force over here to move it upside. When force is put it over here, it's also covered a distance. So what we did is we have seen that force we put and distance it's covered. Now as we know that work is equal to force into distance, so it means the work happens over here. Yeah, just wait. It means we did some work over here, force into distance, we did some work over here. But now what happened, कि when we just like take an example of a ball. When we have taken a ball, okay, in our hand, it's in a rest position, but when we just push it up, okay, up from the ground, so what happens, it will be stop on the one point. What it did, we put the work over here, so what it did, it will do that, it will stop on one point, okay. At that point it will be in rest, not in motion, okay, like this one. Then this will be the height and kinetic energy of that one. Kinetic energy and height is covered because it's stopped over here. Now what we did, it not stop for the 2 seconds, it will just directly come down. I am just giving an example. The kinetic energy will be 0 because it will be in rest. kinetic energy will be 0. And after that, one more thing, that height will be maximum, because it stop on somewhere, it's having a position, so height will be maximum. Height will be max, means maximum. But now one more thing, when it again come down, so kinetic energy is happening, means it's in a motion. But when it's come down and it's in a rest position somewhere, so its kinetic energy will again 0, because it's in a rest when it come down. But here potential energy is maximum, because it's on a height and it's in a position. But it will when come down, so its potential energy will also 0. Now one question arrive, that it's also should potential energy should be maximum. Why potential energy is 0? Because it's in a position over here now. But one thing, that we don't have a height over here. Like in this one position we were having height, so potential energy is maximum. So one thing, that we have a probably need of height in a potential energy, because it's directly proportional. But here we don't have a height, because it's come down and it's in a rest position. So this was the work energy principle, that kinetic energy plus potential energy is equal to work. Like we have a kinetic energy when it move upward, we have a kinetic energy and potential energy when it come downward. With this work, we do the work, kinetic energy and potential energy produced by their own self. So this was the work energy principle. Now after that, we are having one more thing, that when work done against the gravity, so we are having negative work. Like now we have done the work over here, now it's going against, means we are having gravitational force, gf, gravitational field over here. Okay, so when it move upward, means against to the gravity, we are having negative work. When it come downward, okay, in the direction of gravity, we are having positive. How? We also prove this equation, that we should write over here, that work done against the gravity, work done against gravity. So what will what we will receive? We are having minus work, means we are having work in negative, not in positive, because it's against the gravity, mgh. Okay, but when work done in the direction, you can also say in the direction of gravity, so what we will receive? There we will receive positive work. But here will be the sign of minus. How? Because it's having mass, gravity, but height is decreasing. Previously here height is increasing, so we are having positive mgh here, and work will be negative. But here we are having work in positive, because it's in the direction of gravity, but height is decreases, so we are having negative sign. Okay, now let's understand some key point that we have shared over here. There's some reference point. Now one more point I want to add over here. That point shows that when reference point will change, so potential energy will also change. Means every reference point have their own, every potential every reference point having their own energy. Like, so we will write here that also, yeah, when reference point will change, potential energy also change. When reference point will change, means when reference point will change, like as I told you, on the one person was on the height, second one was not. So when reference point will change, potential energy will also change. I will also prove this, that how potential energy will also change. Or you can say that every reference point having their own potential energy. Like, let's suppose over here, okay, firstly I should make a diagram. Let's suppose over here we are having gravity, means earth. One person is standing over here. Okay, this is the height, means this is a building. At the top of the building, this is the second reference, this is the first reference of the person. From its start, this is the second reference of the person. Second person is standing over here. Okay, now what he did, he just put a ball. Wait, I have just make it wrong, I should make it smaller one. Like, this is another building. Here is second reference is starting from here. one person is standing on the building. This is the first reference, this is the second reference. He just push the ball upward, okay, in the height, okay. So it cover the height, okay. So let's suppose it's cover the height that is 0.5 meter, okay. And this was the total height, means it was a height. This is building height will also be counted in the first one reference, because A is standing downward. For his, this will be the 30 meter. Let's suppose this is the height of 30 meter for him, okay. Now one more thing, the second reference is having mass of 1 kg. Let's suppose that both having a mass of 1 kg, okay. 0.5 meter width. Now this is just a 0.5 meter when he pushed the ball from his head, but the total reference from his ground, means his ground is the building top where he is standing, from where he is standing and from where till where ball went. So this was a 2 meter totally. Now we have having three heights over here. One is the total height of the person that is standing on the building, and second is the just height of that where which one ball he pushed up from his head, his mass 1 kg. And third one height is that the person total height from first reference for first person from the his first point, means from his the rest point. You can also say from ground point to the height point where the ball just push up. Now we will prove that how every reference point having their every potential changing of potential energy. So we are having formula of potential energy, that is equal to mgh. Now mass we are having 1. Let's suppose gravity we are taking maximum, that is 10. Height of the first one we were having 0.5, means first one we are having, second one reference we are talking about 0.5, okay. So what we will receive, we have received that 5 joule. Potential energy is 5 joule over here. This is the height of that one where the person is standing on the building and where he pushed the ball from his head, means कि उसने जो अपने सर के ऊपर से मतलब ऐसे बॉल को ऊपर उछलाया कैच करने के लिए, ये वो वाली हाइट है, वो वाली पोटेंशियल एनर्जी है. नाउ वी विल काउंट द पोटेंशियल एनर्जी ऑफ द पर्सन दैट इज स्टैंडिंग ऑन the earth, means the second one is also standing, but second one is standing on the top of the building, but first one is standing on the you can say on the roof, on the floor, means he is standing on the path, means it's a down. So we will take also that 1%. Potential energy is equal to mass will remain same, gravity will remain same, but now we have to count the different heights, means for his there will be the different heights, height 1, height 2 and height 3, because you have to count all till where the ball went. So potential energy is equal to mass we were having 1, then multiply by gravity we were having 10, height. Now talking about height, one height we are having of the ball, that is 0.5. Second height is that is from person to the ball, that is 2. After the third height is that the person is standing in the ground till the height of the ball, so that is 30 meter. Now when we will add this all, so we will get a potential energy that will be 325 joule. Now we have proved over here that every reference point have changed their potential energy, means every reference point have their own potential energy. Like a person is standing on the building floor, building roof, he is having change in potential energy like 5 joule. A person who is standing in the ground, he having change in potential energy, that is 325 joule. Hope you understand today's lecture. Thank you so much for listening.